Hello guys, welcome to today's class on calculus. In the previous video we talked about limits by substitution method. Now in this class we are going to consider limits by factorization method. Okay, so I've always said that whenever a problem is given to us on limits, the first thing to always do is to try out the problem first by directly substituting the limit into the function. Now if you obtain an indeterminate expression, then you can now try any other approaches among the left three, the L'Hopital's rule, the conjugate method, and the factorization method. So in this video we are going to look at a typical example about how the factorization method works. So let's take a look at the question on the board. Question says limit as x tends to minus 3 all over 2 of the given function 4x squared minus 9 all over 2x plus 3. So as always, you always try first by directly substituting the value of the limit into the function. So by substitution, okay, you set x to be equal to the limit of the function, which is minus 3 all over 2. So x becomes minus 3 all over 2. So wherever you see x in this given expression now, you simply put in the value as minus 3 all over 2. So we simply have a limit as s tends to minus 3 all over 2. This function becomes 4 into, I have x squared here, and x is minus 3 all over 2. It becomes minus 3 all over 2 all squared, simply because I have squared attached to this x here. Okay, so I'll put down my minus 9 all over, I have 2 here, put it down. Now I have x there as well, and x is simply minus 3 all over 2. So you attach that minus 3 all over 2. Alright, so you put down plus 3. So this is equal to, now this becomes 4 into, of course, minus 3 squared becomes positive, and the value is 9. So I have 9 all over 2 squared itself becomes also becomes 4. So I have all over 4 minus 9 all over, here I have 2 multiplying minus 3 all over 2. 2 cancels 2. Okay, so I'm simply left here with minus 3, okay, plus 3. All right, so this simply becomes equal to, notice here now, this is 4 into 9 all over 4. So 4 cancels 4. I'm left with 9 here. It becomes 9 minus 9 all over 3 minus 3. And this is equal to 9 minus 9 is 0. All over 3 minus 3 is 0. So this is actually indeterminate. So it means that this limit cannot be solved by direct substitution method. But we can only find that out when we use the substitution method to solve. So it actually means that the limit has failed by direct substitution. So we try the next card. Now you have to look at the function now and see if you can factorize the given function. If it is factorizable, then you use factorization method. But if it is not, you can try the conjugate method or the L'Hopital's rule. So we look at the numerator. Okay, so when factorizing, or when you want to carry out a factorization method, you look at where you have the highest power and see if the variable can be factorized. I have my highest power at the numerator here. I have 4x squared minus 9, and I want to factorize this function. Okay, there are two ways. You can either use long division to factorize this, or you can simply equate the quadratic function to 0 and obtain the values of x. That becomes the factor of the given equation. For instance, the numerator is simply 4x squared minus 9. If I simply equate this to 0, I can have that I can simply have that 4x squared is equal to, if I send minus 9 over here, negative cross and equal to sign becomes positive, so this becomes 9. Therefore, I can simply make x squared subject by dividing 2 by 4. It becomes 9 all over 4. So in order to obtain x, it actually means that x itself is now plus or minus the square root of 9 all over 4. Okay, so this simply implies that x is now equal to plus or minus root 9 over 4 is something as saying root 9 all over root 4. So this actually means that x now has a value of plus or minus root 9 is obviously 3, all over root 4 is obviously 2. So which means x has a value that exists in two ways. So this simply implies that x is either plus 3 all over 2 or x is equal to minus 3 all over 2. So I can simply have this, and if I cross multiply from here, let 2 multiply x, or multiply both sides by 2, obviously this now implies that 2x is actually what equal to plus 3, or same thing here, 2 multiplied by x here becomes 2x equals minus 3. So I can simply send plus 3 over here, send minus 3 over here. This becomes 2x, if positive sign cross an equal to sign, it becomes negative, minus 3, that's equal to 0. Or I can simply send minus 3 over here, this becomes 2x plus 3 equals 0. So these two factors, 2x minus 3 multiplying 2x plus 3, will actually give us a factor of what? 4x squared minus 9. So, alright, therefore, the factors of 4x squared minus 9 is actually, okay, 4x squared minus 9 is actually equal to, this becomes 2x minus 3 multiplied by 2x plus 3. So this becomes the factor of 4x squared minus 9. Alright, so you can now substitute in place of this variable the whole of this. Therefore, the limit of this function becomes now limit as x tends to minus 3 all over 2. In place of 4x squared minus 9, we simply put in what? These factors. So we simply have a 2x minus 3 multiplying by 2x plus 3 all over 2x plus 3. Okay, so if you critically look at the numerator and denominator, you notice that 2x plus 3 can actually strike 2x plus 3. So I am now left with 2x minus 3. Alright, so therefore the limit becomes limit as x tends to minus 3 all over 2. We are now left with 2x minus 3. So we'll have 2x minus 3. Therefore, you set x to now be equal to the limit minus 3 all over 2. So wherever you see x in this expression now, you put in minus 3 all over 2. We now have limit as x tends to minus 3 all over 2. In place of 2, we have, in place of x here, we have 2 into x is minus 3 all over 2 minus, okay, put down your minus 3, and this is now equal to, of course, 2 can cancel 2 here. I'm left with minus 3, okay, minus 3. Therefore, limit as x tends to minus 3 all over 2 of that given function f of x is actually minus 3, which gives us minus 6. Alright, so that is the idea behind factorization method. First of all, you test by substitution. If the limit fails, then you can now try the factorization method. Let's try another example and see. Alright guys, so let's say we are given this other example to evaluate limits as x tends to 3 of x squared minus 5x plus 6 all over x minus 3. Okay, so just like always, I would say you always test first by direct substitution. It is when that test fails that we can now try the next method. Okay, so by substitution, alright, you set x to be equal to the point of the limit. I have limit as x tends to 3 here, so it becomes x equals 3. Therefore, this becomes limit as x tends to 3. Now, in place of x squared, x is saying, we said x is 3, so it becomes 3 all squared. Since x here is squared, minus 5 into, I have x here, so in place of x, we put down 3 plus 6 all over, here I have x, and x is 3, Okay, so you put down your minus 3 and you have this. This is now equal to 3 squared itself is 9. Okay, 5 times 3 actually gives us 15. So this is actually minus 15. Then you put down your plus 6 all over 3 minus 3. So this is now equal to 9 minus 15 actually gives us minus 6. Okay, you put down your plus 6 all over 3 minus 3, and minus 6 plus 6 obviously gives us 0. All over 3 minus 3 also gives us 0, so which is actually indeterminate. So it means that by indeterminate, this limit has failed by substitution method. So we have to try and see if we can factorize any given function there. And of course, the numerator is actually a quadratic equation, so you can use any method at all of quadratic equation to actually obtain the factors of the numerator. So we have x squared plus minus 5x plus 6, and we need to find this factor. So you can either equate this to 0 and solve with the general formula to obtain the value of the factors, that's values of x, or you can simply use the factorization method, which I think is best in this case to obtain the factors. So from factorization method, you actually look for two numbers such that when you multiply the two numbers, you will have the constant value, and when you add the two numbers, you have what the coefficient of x, and the two numbers are simply minus 2 and minus 3, such that minus 2 multiplied by minus 3 will actually give us plus 6, which we'll have as a constant, and then minus 2 adds by minus 3 will actually give us what? Minus 5, which will have as a coefficient of x. So it means that minus 2 and minus 3 are actually the factors of this quadratic equation. So that simply means that this can now be written as you have the whole of this equation now can now be written as x squared. In place of minus 5x, we actually have minus 3 minus 2 minus 3 to give us minus 5. So this actually becomes minus 2x minus 3x, and of course minus 2 minus 3 gives us minus 5. Okay, and then we have here 2 times 3 minus 2 times minus 3 to give us plus 6. So we can actually do that over here. This becomes plus, okay, open bracket, minus 2 multiplies minus 3 in place of plus 6. So we have this. Okay, let me keep this aside. All right, so further on, this becomes x squared. So you simply factor now. You just pick these two, x squared minus 2x, and you also pick minus 3x, okay, and this all together. So I have x squared minus 2x plus, now you pick minus 3x plus open minus 2 multiplied by minus 3. Keep this together as well. Okay, between x squared and minus 2x, x is common between the two of them, so you can actually factorize x. You have x into, I'm left with 1x here minus 2. Of course, x times x is x squared, x times minus 2 gives us minus 2x. Same thing happens here. I have minus 3x here, and I have minus 2 times minus 3. So minus 3 is actually common between these two, so I can pull out minus 3. Minus approaches positive becomes negative, so I have minus 3 actually multiplying by, I'm left here now with x, okay, and I'm left here with minus 2. Remember, minus and plus is actually minus, so I have this. Okay, so at this point, you look at the factors now. I have x squared minus 2, I have x squared minus 2, they have the same factors in this bracket, so pick one of it, x minus 2, and then pick the values outside. I have x and minus 3 outside the bracket, put them in the bracket, x and minus 3. So this becomes the factor of x squared. Okay, so this simply means that x squared minus 5x plus 6 is actually equal to x minus 2, okay, into x minus 3. So if you expand this together, obviously you will get this. So you can do it, try to expand that and see and confirm this result, but I think it's correct. All right, so in place of this now, the limit becomes limit as x tends to 3. Okay, in place of x squared minus 5x plus 6, we now put in the factors, which is this x minus 2 multiplied x minus 3 all over, I have here x minus 3. So all over x minus 3. Okay, you have this. So from here now, of course, x minus 3 strikes x minus 3. You're left with limit as x tends to 3, the function becomes x minus 2. So you simply set x to be equal to the limit, which is 3. Okay, set x to be equal to 3. Therefore, limit as x tends to 3 of that given function f of x is now equal to, in place of x here, we put down 3 minus 2. And the answer is simply 1. Okay. So that is it on factorization method. Let's try one more example before we call it a quit on factorization method for now. Okay. So let's say we are given limit as x tends to 3 of x cubed minus 27 all over x minus 3. So as always, you try by substitution method, and by substitution, okay, simply set the value of x to be equal to the point of the limit, which is 3. Now this becomes limit as x tends to 3. In place of x cubed here, x is 3, so it becomes 3 all cubed minus 27 all over 3 minus 3. And this is equal to 3 cubed is obviously 27 minus 27 divides 3 minus 3. Okay, so this is now equal to, of course, 27 minus 27 is 0. I have 0 all over 3 minus 3 is also 0, which is indeterminate. Okay, so you also have an indeterminate expression. Therefore, you try the next method, and of course, this is actually not a quadratic equation. This is a polynomial having 3 power. Okay, that's third power, which means to actually find the factors of x cubed minus 27, we need to employ the long division approach. So we'll use long division to do that. Okay, so I have here x cubed minus 27 dividing by x minus 3. All right, so this becomes x cubed goes into x, of course. I'm left with x squared. Okay, so you pull it back now. X squared multiplied by x gives me x cubed, and x squared multiplied by minus 3 gives me minus 3x all squared. Okay, so you rule your line, subtract. X cubed minus x cubed is off, that's 0. Now take note here, this becomes minus 27 minus 3x squared. Okay, so minus 3x squared, minus becomes plus. So I have 3x squared, put down your minus 27. Okay, so we have to continue doing this till we obtain 0 as the remainder. Now 3x squared goes into x. One of these x cancels one of these x, so I'm left with 3x. Put it down, plus 3x. Now you fall back again, plus 3x multiplies by x gives me 3x all squared. Now plus 3x multiplied by minus 3 gives me minus 9x. Okay, and then you rule, put your subtraction line. 3x squared minus 3x squared is off, that's 0. Then also pay attention now, this becomes minus 27 minus 9x. Minus becomes plus, so I have 9x minus 27. Okay, 9x can still go into x. 9x goes into x, the x cancels out, I'm left with plus 9. So you fall back again, plus 9 multiplied by x gives me 9x, plus 9 multiplied by minus 3 gives me minus 27. Okay, so you rule and you attach your negative sign. 9x minus 9x is off, that's 0. Also take note, minus 27 minus minus 27 becomes minus 27 plus 27, which is actually 0. So the remainder is 0. It means now that the factors of x cubed minus 27 are actually, remember, the quotient multiplied by the dividend. So that becomes x squared plus 3x plus 9 multiplied by x minus 3, okay, plus the remainder, and the remainder is 0. So this becomes the factors of x cubed minus 27. So in place of x cubed minus 27 in this equation, we simply replace with these factors, okay? All right, so this becomes limit as x tends to 3. So in place of x cubed minus 27, the factors are actually what? This. So I have x squared plus 3x plus 9 multiplies x minus 3 all over x minus 3. So notice from here that x minus 3 can actually strike x minus 3, and therefore this becomes limit as x tends to 3 of x squared plus 3x plus 9. So at this point, you set x to be equal to the point of the limit, which is 3. Set x to be equal to 3. Therefore, this becomes limit as x tends to 3 of this given function. Now, in place of x squared there, we have 3 all squared plus 3 into, in place of x here, we have 3, okay, plus 9. And this is now equal to 3 squared is 9 plus 3 times 3 is also 9 plus 9 here, which actually gives us 27, and that becomes the answer to that question. All right, guys, so that is how you solve your questions on limits by factorization method. Always keep it in mind, you test first by substitution. If the limit fails by substitution, then you have to try and see any other alternate method to see if you can solve. If the function can be factorizable, you employ the factorization method. If it cannot be factorizable, you check if you can conjugate. If it can be conjugated, then you go with conjugate method, else you try the L'Hopital's rule. I will see you in the next video with the conjugate method. Stick tight and thanks.